Welcome to this talk about Google Play app signing. This is a really exciting moment for us. We've been working on this product for nearly a year, so it's great to be able to talk to you about it. I'm James. I'm the product manager for app signing, and this is...
Hi, I'm Anthony. I'm the engineering lead for Google Play app signing.
So let's start by outlining the problem that we're trying to solve. Android requires that all APKs be digitally signed with an app signing key and a certificate before they can be installed. When you sign an APK, the signing tool attaches a certificate to the APK. The certificate serves as a fingerprint, which uniquely associates your APK with you and your corresponding private app signing key. This helps Android ensure that any future updates to your APK are authentic and come from the original author. You must use the same app signing key and certificate throughout the lifetime of your app in order for users to be able to install new versions of your app. Maintaining the security of your key is therefore of critical importance, both to you and your users. If a third party should be able to take your key without your knowledge or permission, that person could sign and distribute apps maliciously that replace your authentic apps or corrupt them. Such a person could also sign and distribute apps under your identity. Your private key is required for signing all future versions of your app. If you lose or misplace your key, you will not be able to publish updates to an existing app. You cannot generate a previously generated key. Your only options then would be to publish a new app under a new package name and ask all of your users to move across. This would obviously be a terrible experience. Developers who take such care in grafting great apps and wonderful experiences for users shouldn't need to be experts in security. You shouldn't ever be in this situation that the president of RV App Studios had to face when they were getting started. So that's why we've been working on a solution. You may have heard that we launched this product. App signing is an optional program for developers that provides a secure means of handling your APK signing key. Previously, the burden for signing and protecting keys was entirely on each individual app developer. And we've seen instances of key being lost or compromised. And in those situations, there was nothing that we could do to help. With Google Play app signing, developers' keys are stored on Google's infrastructure, and developers benefit from Google's ongoing investment in technical security. So let me run through how this works. Today, a developer signs their APK with an app signing key. The signature gets attached to the APK, and the app is uploaded to Google Play. Play sends an exact copy of the APK, signature and all, to the user, and the user gets the app signed by the original key. All subsequent updates follow the same path. With Google Play app signing, things look a little different. Now, the developer signs their APK with an upload key. The upload key signature is attached to the APK, and the developer uploads that APK to Play. The upload key is used by Google to authenticate the developer, and that's its only purpose. The upload key can therefore be reset. Play re-signs the APK with the original app signing key, and the user gets an APK signed with the original key, just like in the scenario that is today. So how does this solve your problem? Well, we've had several partners using Google Play app signing for a while now, and the feedback has been really positive. Here, Robinhood speaks to the layer of safety that we've added, while at the same time all but eliminating the worry of having lost or stolen keys. And it's really easy to get started. You just upload your key, create a new one, and then you're done. In fact, it's so easy, I'm going to walk you through the entire process right now. So, log into the new look Play console. You've seen the material design, right? Find the app signing page. It's under Release Management in our new Material Design menu. You need to read and agree to the terms. The change to go into app signing is for the lifetime of your app, so please be sure that you want to continue before you begin. We don't intend to allow withdrawal from the program. If you wanted to change the app signing key or go back to signing yourself, you would need to create a new package name and release a new app and migrate all your users across, similar to losing your key today. So please be sure that you want to continue before you begin. Next, you've got to find your current key store file. Here are some of the common places that developers have told us that they keep their key. Your local development machine, your CI server, your code repository, or maybe even a secure server. Then you're going to download our tool to encrypt your app signing key. This tool uses Google's public key to encrypt your key prior to network transfer. If you want to inspect the source code for this tool, you can. Now, select your encrypted app signing key and upload it to Play through the form. Now, you're going to generate the new upload key. This will be used to authenticate your APK uploads with Google. We remove this signature and re-sign with the original key before distributing the app. And you generate a new key really simply using the key tool. Finally, you're ready to register the upload key with Google and then enroll your app. Once you click Enroll, your app is enrolled permanently, and Play Console will only accept uploads signed with the upload key. So please be sure that you're ready to transfer over. And that's it. You're done. Hopefully, the transition is seamless and smooth, just like it was for Roblox. For new apps, it's even simpler. We'll create and use a new app signing key to sign your app before it's deployed to users. The key that you use to sign your APK before uploading to Play Console becomes your upload key. And that's it. Now, Anthony's going to talk about the security aspects of this product.
Thanks, James. So when we were designing this product, security was our #1 priority. Google has a long history of strong and ongoing investment in security. We have over 750 engineers at Google working on our security systems. And so we have built upon that investment in building this product. So let me go into some more detail on some of the security features of Google Play App Signing. So I want to first talk about the security considerations involved with importing your private keys. In designing this process, we wanted to make sure it was as secure as possible. So James has explained that in order to encrypt your app signing private key for transfer, we provide you with a simple command line tool called the PEPK tool. I like to call it PEPK. It stands for Play Encrypt Private Key. So this tool exports your app signing private key from a Java key store and then encrypts it immediately, ensuring that your private key is never left in plain text during this operation. And if your keys are not stored in a Java key store, then we also provide the source code of the tool. So you can write your own code to export and encrypt your keys from wherever they are stored. The encryption we use is public key hybrid encryption based on Shoup's ISO standard. Specifically, we use P256 elliptic curve asymmetric encryption with AES symmetric encryption. And because we use asymmetric encryption, once encrypted, your app signing private key can only be accessed by our internal secure key management system. So intermediate servers along the way can't access the key. Now let's talk about our secure key management system, a specific dedicated service for managing private keys. And in managing these keys, we follow industry best practices. So in more detail, the keys are never exposed outside of this system. And these keys can only be used to sign the APKs that you have uploaded. And in particular, when we go to sign an APK, the signing operation is performed within this system. So the keys don't leave the system in order to sign your APK. Furthermore, all signing operations performed are logged and internally auditable, and access to this system is tightly restricted. Now, to protect the keys within this system, we store the keys such that they are strongly encrypted at rest. The keys are never stored in plain text. And to prevent key loss, we make very frequent backups of our primary storage. These backups are themselves strongly encrypted, and we regularly test restoring from these backups. You can find out more information about Google's security practices in our public Google security white papers published online. Finally, I want to talk to you about this new key we have introduced into the process, called the upload key. As James has explained, the upload key is used by Google Play to verify that the uploaded APK comes from the correct developer. We verify the validity of the upload key signature prior to signing with the app signing key. Now, unlike the app signing key, the upload key is only verified by Google Play and not the Android framework. And that means it's possible to reset it in case the developer loses it or it is compromised. So if, in the unfortunate situation, the upload key does become lost or compromised, you can contact Google Play Developer Operations and request that your upload key be reset to a new upload key that you generate. This process will take a couple of days, as we will need to securely verify your identity, and then you can resume uploading APKs by signing them with your new upload key. Now over to James to talk about what enrolling in Google Play app signing enables us to do for your app.
Thanks, Anthony. So, once Google Play signs your app, you can probably guess what's coming. We can also start to provide optimization services at your request. So, how is this possible? You provide us an APK signed with the upload key. We verify your identity and then remove that signature. There is now a window of opportunity before that APK is signed with your app signing key where we can apply optimizations to your app. We want to use this opportunity to provide services to developers. Think about it as applying the power of Google and text best practices to your app. So the first optimization we decided to focus on is making apps smaller. We think we can have a great impact here. We know that developers care about APK size because users do. Download cancellations are correlated with app size. If a user attempts to download an app and it takes too long or it looks like it's going to be too big, it's more susceptible to getting cancelled. And we know that larger apps are more likely to be uninstalled by a user looking to free up space on that device. If you're interested in what you can do to make your app smaller, make sure you check out the video from the Slimming Down Your APK talk, which happened this morning.
So when looking at how we could reduce app size, we started by looking at what takes up the most space inside an APK. So we analyzed all the apps in the Play Store and looked at the proportion of space taken up by each file type inside the average APK. And the chart on this slide shows you the results of this analysis. What you can see is that the top contributors to APK size are .so files, or native libraries, and PNG files, images. And together these take up roughly 40% of an APK's size on average. Now, if we look inside some APKs, we can see why these file types take up so much space. Here we have an example APK where we visualize the contents of the APK by size, the size of the boxes indicating the relative size of each component. And I'm sure many of your apps would look similar to this. What we see is that because of the diversity of devices in the Android ecosystem, developers include native libraries for different architectures, so ARM, x86, MIPS, sometimes the 64-bit variants as well, and drawables for different screen densities, low density, medium density, high density, extra high, extra extra high, extra 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 high. We got really creative at the end there. And this is a good thing, because it means that apps run at their best on each device. They have images at the right density and native libraries compiled for the correct architecture for that device. But the consequence of this is that for a specific device, a lot of the content of an APK is unnecessary. So if I have a phone with a 32-bit ARM architecture and an HDPI screen, then I only need the contents of the boxes in blue. And the boxes in green are completely unnecessary and unused for that specific phone. But if I had a tablet with an x86 architecture and an XX HDPI screen, then I would need a completely different subset of the boxes. Now, you could, in the past, manually create device-specific APKs by generating multiple APKs, each with only one density and one native architecture. But it's a lot of effort. And in fact, we recommended you didn't do this because it's so complicated. And so we found that less than 1% of apps on the Play Store actually do this. But now, as James has explained, with Google Play App Signing, we can automatically generate these APKs for you and deliver to each device only what that device needs. So how does this work in more detail? So a developer, uploads a universal APK that contains drawables for multiple densities and native libraries for multiple architectures. Then from that universal APK, we generate multiple APKs that are optimized for specific devices. So for native libraries, what we'll do is we'll remove all the libs directories except for the one corresponding to the device's preferred architecture. So if you have an x86 device, we will remove the ARM and the MIPS directories from the APK that we will deliver to that device. For drawables, we will remove all the drawable resources that would not be loaded for that device's screen density. So if you have included an MDPI, HDPI, and XHDPI version of an image in your APK, then for an MDPI device, we will only keep the MDPI resource in the APK that we deliver to that device. And then after removing these drawables, we modify the resource table accordingly to no longer reference these removed files. Now, because we only removed the native libraries and resources that would not have been loaded on that device in the first place, and keep the ones that would have been loaded by that device, you should see no difference in the behavior of your app, except, of course, that it will be smaller. Now, we call these APKs that we generate derived APKs, as they are derived from your uploaded APK. Each of these derived APKs will have the same version code as the version code in the uploaded APK, and we add an extra field in the manifest that we call the derived APK ID in order to distinguish them. So then what does this mean for you if you were enrolled in Google Play App Signing and have enabled these optimizations? So firstly and most importantly, it means that the APKs we deliver to your users are smaller, saving users bandwidth and space on disk. It also means that if you were previously reluctant to add support for new architectures or screen densities because you worried about bloating your APK, then now you don't need to worry. We've had developers in the past tell us they don't want to add support for 64-bit architectures because it will result in a significant increase in their APK size. But now, since we will only include the necessary architectures for each device in the APK we send down, you can add support for new architectures without affecting APK size for users. Finally, if you were previously building multiple APKs for different densities or different native architectures, you won't need to anymore. So instead of uploading 4 different APKs for different native architectures, or 6 different APKs for different screen densities, or maybe you were really diligent and had 24 different APKs, each for a specific native architecture and screen density, now you don't need to do that. Now you can just upload a single universal APK, and Google Play will do the work for you. I'll hand back to James now to talk about some of the results we've seen with some of our early partners.
So hopefully this is pretty cool, right? Hopefully for you, if you're using multi-APK, this is going to change how you build, how you do things, hopefully make things a lot better. So we're just getting started exploring this area, and it's really early. But we tried it out with some apps that are in our early access program, and we expect the average savings to be about 15%. However, some apps see even better results. Deliveroo was 33% smaller after optimizations, and the 7-minute workout app was nearly a half smaller at 48%. When we talked to developers about these changes, they got really excited. One developer said, "We just put things in the right place, and Google does the heavy lifting." And that's exactly what we're going for. You can do this yourself, but it's complicated. And we want to offer services that apply best practices automatically for developers. So how do you try this out? Now, to get started testing, the first thing you should know is that you can enable app optimizations for specific APKs when you upload them to Play. That means that, for example, you could enable optimizations for a specific APK, and then try it out in your alpha or beta channel. You are using alpha and beta channels, right? We have over 250,000 developers using alpha beta, and if you aren't already using it, then you probably should be. They're a great way to test out new features on a subset of your users before releasing the APK to everyone. Once you're satisfied the optimizations make sense for your app, you can enable APK optimizations for all APKs that you upload. If you want to download and inspect an APK that is signed by Play, you can do this at any time once they're generated, before or after they're released. After you upload an APK to the Play console, it generally takes less than 5 minutes to generate all of the derived APKs, and then you can go into the new artifact library in the Play console. You're going to select the APK that you uploaded and click on the download button to get this pop-up. Now, you can download the original APK, you can download a derived APK by entering in the derived ID, or you can type in a specific device to get the APK that Play would send to that device.
You might also want to try things out locally during development without uploading to the Play console to see how your app will perform when optimized. So there are two ways you can go about this and simulate the optimizations that we'll do on the server side while you are doing local development. One way is you can temporarily modify your Gradle config to output the density and native architecture optimized APKs just by adding the lines shown here. What this will do is it will cause your Gradle build to output multiple APKs, each targeted to a single screen density and native architecture. Or you can build your universal APK that you would upload to Play, and then run a new command that we've added in AAPT2 that will generate the optimized APKs from the universal APK. This command is actually what we run on the server to generate the optimized APKs from the APK that you upload. One other important thing to note for local testing is that many APIs and services require that you register your signing certificate of your app in order for them to work. For example, the Firebase SDK, the Google Maps API, and the Facebook SDK all require this. Now, if you're testing locally and you've enrolled in Google Play App Signing, you will likely no longer have access to the app signing key, as it will be managed by Google Play. So you're going to be signing your local builds with the upload key or another key. Remember to register this local key in addition to your app signing key with all the relevant APIs and services that your app uses in order to ensure that your app will continue to function correctly when testing locally. Finally, one other thing is that we've also updated how our in-app purchases We've also updated our in-app purchase checks to skip the certificate check for users that are registered as licensed testers to make local testing of in-app purchases easier. So if you want to test in-app purchases without uploading an APK to the Play console or without having it signed with the app signing key, all you need to do is register your account as a licensed tester in the Google Play console. So over to James now to wrap things up.
OK, so when can you get Google Play App Signing? Well, it's available today. App optimizations we're trialing in beta with a few partners at the moment, and we're hoping to widen the beta in the near future. So if you're interested in optimizations, please go ahead and sign up for app signing as soon as possible. So thank you very much for listening. You can come and see us later in the Sandbox C across the way, but we'll also take questions just now if you have any. There's mics here and here in the audience. Thanks very much.